In this video, I would like to explain about a special method called the Kramer's rule to solve systems of linear equations. The Kramer's rule is named after Gabriel Kramer during the year 1704 to 1752. This rule is nothing but a formula that uses determinants to solve systems of n linear equations where the n linear equation have got unique solutions. Sometimes you may have a system which has no solution or infinite number of solutions, but this rule will not apply to those. It will apply only to systems of linear equation which has got unique solution. Let us take this system in terms of x1, x2, x3, and we have the coefficients a11, a12, a13, b1, etc. All these are absolute constants. So this is a system of three linear equations in three variables. We are trying to solve for these unknowns x1, x2, and x3 in terms of these constants a11, a12, etc. a33, b1, b2, b3. Now in Kramer's rule, we are going to find the coefficient matrix A. The coefficient matrix A is nothing but the matrix obtained by using all the coefficients of x, y, z, or x1, x2, x3 from those three equations. And A1 will be a matrix where the first column is replaced by the first column in your previous matrix is replaced by just the constants. The constants on the right hand side were b1, b2, b3. So you are replacing a11, a21, a31 by b1, b2, b3. The same way, a2 is replaced by the second column by the columns in the constant. A3 will be a matrix replacing the third column by the column of the constants in the system. So these are our values of A, A1, A2, and A3. With the help of these matrices and its determinants, we are going to find the solution to this. The Kramer's formula uses all these determinants of these matrices, and the value for A, A1, A2, A3 will be used, and they are trying to get the value for x1, x2, and x3. So if the system is given like this, then in general x3 will be determinant A3 by A. The same way x2 will be determinant of A2 by A. x1 will be determinant of A1 by A. So the Kramer's rule says if A is the coefficient matrix, A1, A2, A3 are the changing the columns using the constant, then x1 will be determinant of A1 by determinant of A, x2 is determinant of A2 by determinant of A, like that xn will be determinant of An by determinant of A. Let us try to solve this system using Kramer's rule. We have simultaneous equations in terms of three unknowns, x1, x2, x3, and the constant is 20, 4, and 16. So here the coefficient will be 1, 1, 1, 1, negative 1, 1, 2, 1, negative 3, and the constant will be 20, 4, 16. So your x1 will be in the denominator for x1, x2, x3 will be the same, which is just the coefficient, but the numerators of x1, x2, x3 will be a little different. In x1, the first column is replaced by the constant. For x2, the second column is replaced by the constant. For x3, the third column is replaced by the constant. So when you get the values of these determinants, the numerator will be 40 divided by 6. And x2 is 20 by 3, x3 is also 20 by 3. We can also use our TI 83 and 84 to find the determinant values. Instead of doing it by hand, we can use our graphing calculator. When we use our graphing calculator, first of all, we have to enter the corresponding determinants. So suppose if I am trying to enter the determinant A or delta, which is in the denominator of all those x1, x2, x3, we know that it is 1, 1, 1, 1, negative 1, 1, 2, 1, negative 1. In order to enter this, we press second x inverse, which will give us the matrix. In that we have to edit. So this is a 3 by 3 matrix. We'll be editing the 3 by 3 matrix. And once when we enter and edit this matrix, we have to select, under the matrix, we have to select the math where we find the determinant of A. When we press I think that will be the first one. Find the determinant of A, that immediately gives you the value 6. So the same way we can find the value of the determinants AX, AY, Z and all that are the determinant for x1, x2, x3 can be obtained, and you can easily find what those values are using the graphing calculator. So this video helped us to understand this Kramer's rule and also apply Kramer's rule to get solutions for systems of linear equations. We used a system of linear equations in 3 unknowns. The same rule is applicable for systems of equations in 4 variables or 5 variables, etc. Even systems of equations in 2 variables can also be simplified using the Kramer's rule. Hope this video was helpful in understanding how to solve systems of linear equations using Kramer's rule. Thank you for listening and thank you for watching.